Okay, we're going to do question number 60 now from page 443, and this is different than the other problems that you've been doing so far, and we'll show you how this works. First of all, in the problem, we're given ammonium nitrate, NH4NO3, is going to be forming, and by the way, this is a solid, and that's very significant for gas laws, so I'll let you know what that is in just a moment. But we're going to form this guy, which is a gas, and we're going to form, and this is dinitrogen monoxide. Then we're also going to get water. And to balance these four hydrogens, I've got to use a coefficient of 2 here on the water, and then everything balances, because we have 2 nitrogens here to 2 nitrogens, and then we got 4 hydrogens to 4 hydrogens, and we have 3 oxygens, 1 here and 2 here. Now let's do with the givens. Aside from the formula or the equation of what we're doing, let's do the given and find. And our given in this case, we have a volume of N2O is going to be equal to 0.100. There, I think that looks okay. And that is liters. And we are at STP, they tell us, and because we're at STP, we know that the pressure is equal to 1 atmosphere, and that the temperature is going to be equal to 273 Kelvin. And now we are asked to find how many grams of ammonium nitrate we have, NH4NO3. So, what we do, we have here a volume, a pressure, and a temperature, and what we want to do is find the number of moles of, in this case, it'll be N2O. So, PVNRT is going to do the job, but the number that we get when we run PVNRT is not going to be the grams that we're looking for. It's going to be the moles, and it's going to be the wrong stuff. So the way we're going to use our stoichiometry, which is using these coefficients and their relationships to each other to solve our problem, we can't do that until we find out the number of moles of this guy, because we can't do liters on a substance that is a solid. It won't work. You can only do liters being proportional when you have 2 gases, and these guys are both gases. Okay? So, pressure is going to be 1 atmosphere, and volume is going to be 0.100, and that is in liters, is equal to our moles that we're looking for. R is 0.0821, and temperature is 273 Kelvin. Got all of that information up here. Okay, so when we solve for N, we are going to divide both sides of this thing by this number, 0.0821 times 273 Kelvin, and 0.0821 times 273 Kelvin. And now when you run that on your calculator, you see this guy's going to cancel, and this guy's going to cancel, as will the kelvins. And let's go ahead and run it. We've got 1 atmosphere times 0.1, and you don't have to put in the double zeros. Calculator doesn't know the difference. Now we divide by 0.0821, divide one more time by 273. And the number we get is going to be N is equal to 4.46 times 10 to the minus 3, according to the calculator. Let's put that into just a decimal form. It'll make our next calculation easier. So this is going to be 0.0046 0.00446, and that's going to be moles. So now we can use this relationship right up here and say that because our relationship here, moles to moles, is 1 to 1. So I have 0.00446 moles, and in this case I have the N2O, which is what we just found, over 1. Now I'm going to figure out my moles of this to this, which is 1 to 1. So the ammonium NH4 nitrate NO3 divided by the, this is 1 mole, and this is 1 mole. A little sloppy there, sorry. And we got the N2O down here. And so our answer, of course, is going to be moles of ammonium nitrate is the same as the moles of the N2O. So 0.00446. I really didn't need to do that calculation. I could have done that in my head. You could have done it in your head. But I wanted you to see how we get our relationships out of the balanced equation. And this is moles of NH4NO3. Now, we were not asked to find moles. We were asked to find grams. Oh, darn. So, we got one more calculation to do. Yeah, this little guy's a stinker, isn't he? 0.00446 moles over 1. The molar mass of ammonium nitrate. When we work this out, we've got nitrogen in this formula. Let's see, where's the formula? Where's my formula? Okay, let's put this one. You can see there's 2 nitrogens, 4 hydrogens, and 3 oxygens. So 2 nitrogens is going to be 28 grams. We're figuring molar mass now. We got 4 hydrogens is equal to 4 grams, and 3 oxygens. And we get these off the periodic chart. Nitrogen is 14, 2 of them 28. Hydrogen is 1, 2 of them are 4. And then when we have 3 oxygens, 3 of those guys is 16. 16 times 3 is 48. And our total here is going to be 80 grams, is equal to 1 mole of this stuff. So we're going to have 80 grams on top and 1 mole on the bottom, so that the moles cancel. And we wind up with a number, let's work that out, clear, 0.00446 times 80 is equal to 0.3568, when we're going to round that and make it 0.357, and that is grams of ammonium NH4 and O3 nitrate. And there you have it.